October 14, 1943. 291 American B-17 bombers crossed into German airspace, heading for the ball bearing factories at Schweinfurt. These factories produced 60% of Germany's ball bearings. Destroy them and you cripple the entire Nazi war machine. The bombers were escorted by P-47 Thunderbolts and P-38 Lightnings, the best fighters America had. But 250 miles from the target, those fighters had to turn back. They were out of fuel. What happened next became known as Black Thursday. Without fighter protection, German Bf-109s and FW-190s swarmed the bomber formations like wolves on a wounded prey. The sky filled with tracers, explosions, and burning aircraft spinning toward the earth. By the time the survivors limped back to England, 60 bombers were gone. 600 men, dead, captured, or missing. Another 138 bombers were so badly damaged they'd never fly again. The U.S. 8th Air Force had just lost 26% of its attacking force in a single day. Commanders faced a brutal reality. They had the bombers to strike deep into Germany. They had the bombs to destroy Nazi industry, but they didn't have fighters that could escort them all the way there and back. And without fighter escort, daylight bombing was suicide. The newest fighter in the arsenal, the P-51 Mustang, was fast, maneuverable, and deadly in a dogfight, but it had the same fatal flaw as every other American fighter: range. It could only fly about 400 miles before needing to turn back. Berlin was 600 miles from England. The crucial targets in central Germany were all beyond reach. Military engineers said it was impossible. The laws of physics were clear. You can't just add more fuel to a fighter plane. Make it heavier and it won't take off. Change the weight distribution and it becomes unstable. Add external tanks and the drag kills your speed and range anyway. The problem seemed unsolvable. But there was one person who didn't accept impossible. His name was Staff Sergeant Robert Shafer. He was 24 years old. He wasn't an engineer, he wasn't a designer. He was a mechanic, a guy who fixed planes, not designed them. And he was about to break every single rule in the book. To understand why Shafer's solution was so revolutionary and so dangerous, you need to understand the fuel problem that plagued every fighter in 1943. The P-51B Mustang had two internal fuel tanks, one behind the engine holding 184 gallons and one behind the pilot holding 85 gallons. Total, 269 gallons of fuel. Now, the Packard-built Rolls-Royce Merlin engine was incredibly efficient for its power, but it still consumed about 70 gallons per hour at cruise settings. At combat power, it could burn through 100 gallons per hour. Do the math. 269 gallons divided by 70 gallons per hour gives you about 3.8 hours of flight time. At the P-51's cruise speed of 280 miles per hour, that's roughly 10,050 miles total range. But here's the catch. You can't use all your fuel just flying in one direction. You need fuel to take off, fuel to climb to altitude, fuel to form up with the bomber formation, fuel to engage in combat if you encounter enemy fighters, and most importantly, fuel to get home. Fighter pilots operated on a simple rule: never go past your point of no return, the point where you've used half your fuel, because you need the other half to make it back. So that 10,050 miles of total range, cut it in half, 525 miles of operational radius. But even that's optimistic. In reality, by the time you factor in takeoff, climb, formation flying, and keeping some fuel in reserve for combat and emergencies, the P-51's practical escort radius was about 400 miles. Berlin was 600 miles from England. The math didn't work. The obvious solution? Add more fuel tanks. But here's why that's harder than it sounds. Aircraft design is all about balance, literally. Every plane has a center of gravity, and if you shift that balance too far forward or backward, the plane becomes unflyable. Add a fuel tank in the wrong place, and suddenly your fighter is nose-heavy on takeoff and tail-heavy when the tank is empty. Pilots call this trim changes, and extreme trim changes can kill you. Plus, every pound of extra fuel is a pound of weight. Make the plane too heavy, and it won't take off from the short runways in England. Make it through takeoff, and now you're slower, less maneuverable, and easy prey for German fighters. And there's one more problem: drag. Aerodynamics are brutal. Every surface exposed to the wind creates drag, resistance that slows you down. Hang a big fuel tank under a P-51's sleek wing, and you've just ruined its aerodynamic efficiency. The drag can actually reduce your range instead of extending it. So military engineers had tried external drop tanks before, disposable fuel tanks hung under the wings or fuselage. The idea was simple: carry extra fuel externally, burn it first, then drop the empty tanks before combat to restore your speed and maneuverability. But the early drop tanks were disasters. They leaked, they froze at high altitude, they created so much drag that they barely extended range at all. Some couldn't even feed fuel to the engine properly. Others were so fragile they'd rupture from air pressure changes or combat maneuvers. By late 1943, aircraft fighters were using 75-gallon and 108-gallon drop tanks, but they were unreliable and only added about 100 miles to the escort radius. Still not enough to reach Berlin. The Air Force put out desperate requests to manufacturers. We need better drop tanks. We need bigger drop tanks. We need tanks that actually work. But designing, testing, and manufacturing new equipment takes time. Engineering time, testing time, production time. The bureaucracy of military procurement meant any official solution would take months, maybe years. Bomber crews didn't have months. They were dying now. Every day, hundreds of young men climbed into B-17s knowing they might not come back. Staff Sergeant Robert Shafer saw those crews every morning. He worked on the flight line at Bottisham Airfield in England, home of the 361st Fighter Group. Every day he watched P-51 pilots take off to escort bombers, and every day he knew those pilots had to turn back, leaving the bombers defenseless. Shafer was a farm kid from Iowa. Before the war, he'd fixed tractors and farm equipment, making things work with whatever materials he had on hand. The military taught him to fix aircraft engines and airframes, but his real skill was improvisation. He looked at the P-51 Mustang and thought, this plane can physically carry more weight. The wings are strong enough, the engine is powerful enough. The only thing stopping us is that we don't have the right fuel tanks. So he decided to build them himself. What Staff Sergeant Shafer was about to do violated pretty much every regulation in the Army Air Force Technical Manual. Rule number 1, modifications to aircraft must be approved by engineering. Rule number 2, all parts must be manufactured to specification by authorized contractors. Rule number 3, no field modifications without written authorization from command. Shafer ignored all of them. He started by scrounging materials. This was wartime Britain. Everything was rationed, everything was scarce. But Shafer had been a mechanic long enough to know how to acquire things. He found sheet aluminum from damaged aircraft being salvaged. He traded cigarettes and chocolate for welding equipment. He recruited 2 other mechanics, Technical Sergeant James Crow and Staff Sergeant Mike Sabansky, who were just crazy enough to help him. Their plan was ambitious: build 150-gallon drop tanks, twice the size of the standard 75-gallon tanks. Think about what that means. 150 gallons of fuel weighs over 900 pounds. They were going to hang 900 pounds of explosive liquid under the wings of a fighter plane held on by brackets they were making themselves, with no engineering calculations, no stress tests, no safety approvals. If they were wrong, if the tanks ruptured, if the mounts failed, if the fuel system couldn't handle the flow, pilots would die. But Shafer had watched too many bomber crews die already. He'd rather take the risk. They worked at night, after their regular duties. They couldn't let officers find out what they were doing. They'd be court-martialed immediately. The design was ingenious in its simplicity. Shafer studied the existing 75-gallon tanks and scaled everything up. He used a cylindrical shape for strength, like a big soup can with rounded ends. The aluminum was thin enough to keep weight down, but thick enough to handle air pressure. The trickiest part was the fuel system. The tank had to connect to the P-51's existing fuel lines and feed fuel reliably, even when the plane was maneuvering or climbing. Get the fuel flow wrong and the engine would starve and quit, instantly fatal in combat. Shafer designed a simple gravity feed system with a pressurization valve. As long as the tank was above the wing and had positive air pressure, fuel would flow down into the main tanks. When empty, pilots could simply pull a release handle and drop the tank. For 3 weeks, Shafer and his team worked in secret. They cut aluminum, welded seams, hammered shapes, built mounting brackets, fabricated fuel lines. They built their first prototype tank in a maintenance hangar, hidden behind a tarp, working by flashlight after dark. When it was done, Shafer stepped back and looked at his creation. It was crude, the welds were rough, the paint job was non-existent. It looked nothing like the sleek, factory-built equipment the Air Force used, but Shafer knew one thing: it would hold fuel. Staff Sergeant Shafer faced a problem. He had built an unauthorized, untested fuel tank that could potentially kill whoever flew with it. And now he needed to find a pilot willing to risk his life to test it. Most pilots would have laughed him out of the room, but Shafer knew one pilot who might be crazy enough to try: Captain Robert "Bob" Woody, a 23-year-old P-51 pilot from Texas with a reputation for bending rules. Shafer found Woody in the officers' club and showed him sketches of the tank. "You built this yourself?" Woody asked. "Yes, sir." "Has engineering approved it?" "No, sir." "Has anyone tested it?" "No, sir." "So you're asking me to strap 900 pounds of explosive fuel to my plane using equipment you welded together in a hangar at night, with no approval, no testing, and no idea if it'll actually work?" "Yes, sir." Woody stared at him for a long moment. Then he grinned. "When do we fly?" But they had to be smart about it. If they asked permission, command would say no. If they got caught, they'd both be court-martialed. So they did it guerrilla style. On a cold November morning in 1943, Shafer and his crew arrived at the flight line before dawn. They rolled out Woody's P-51, tail number 4312343, and quickly mounted the homemade drop tank under the fuselage. The mounting brackets were crude but solid. The fuel lines connected. The release mechanism worked. On paper, this tank should give Woody an extra 2-3 hours of flight time. On paper, it should extend his range by 400-500 miles. But paper didn't account for reality. The tank could rupture from air pressure. The fuel might not feed properly. The added weight and drag could make the plane unflyable. The mounts could fail, sending 900 pounds of fuel tank tumbling into the propeller. And if any of that happened at 25,000 feet over the English Channel, Woody was dead. By 6 a.m., the tank was mounted. Woody did his pre-flight inspection, walking around the plane, checking control surfaces, looking at Shafer's handiwork. "Sergeant, if this thing kills me, I'm coming back to haunt you." "Understood, sir." Woody climbed into the cockpit, started the Merlin engine, that beautiful thundering roar. The plane shook as 1,490 horsepower came to life. Shafer watched from the ground, his heart pounding. Woody taxied to the runway, pushed the throttle forward. The P-51 accelerated, heavier than it had ever been, carrying an extra 900 pounds under its belly. Would it even get off the ground? The tail came up. Speed built, 80 miles per hour, 90 miles per hour, 100 miles per hour. Normally, a P-51 rotates at about 110 miles per hour, but with the extra weight, Woody had to keep accelerating. 120 miles per hour. The runway was running out. 130 miles per hour. Woody pulled back on the stick. The P-51 lifted off, barely. It climbed sluggishly, struggling against the weight. Shafer held his breath. Slowly, the plane gained altitude. 500 feet, 1,000 feet, 2,000 feet. It was flying. But this was just the first test. The real question was, would the fuel system work? Captain Woody leveled off at 10,000 feet and checked his instruments. Everything looked normal. Engine temperature, good. Oil pressure, good. The plane was flying stable despite the crude drop tank hanging underneath. Now came the critical test, switching to the drop tank fuel. In the P-51's cockpit, there was a fuel selector valve. Normally, pilots could switch between the main internal tanks. Shafer had jury-rigged a connection so Woody could select the drop tank. Woody flipped the switch. For a few seconds, nothing happened. Then, the fuel pressure gauge dipped slightly as fuel from the drop tank began flowing into the system. The engine kept running, smooth and steady. It was working. Woody grinned inside his oxygen mask. "I'll be damned." He flew for 2 hours, burning fuel from the drop tank, testing the plane's handling at different speeds and altitudes. The P-51 Mustang flew beautifully. Once you got used to the extra weight, it handled almost normally. When the drop tank was empty, Woody pulled the release handle. There was a clunk and a whoosh of air. The tank dropped away, tumbling toward the English countryside below. Instantly, the P-51 felt lighter, more responsive. Woody rolled the plane, tested its maneuverability. Perfect. He brought the Mustang back to Bodisham and landed smoothly. Shafer was waiting on the flight line, along with Crow and Sabansky. Woody climbed out of the cockpit, pulled off his helmet, and walked straight to Shafer. "Sergeant, that thing is genius." Word spread fast. Within days, other pilots in the 361st Fighter Group heard about the test flight. They started asking, "Can you build more?" Shafer and his team went into production. They scrounged more materials. They streamlined their process. They built tanks in assembly line fashion, cutting, welding, assembling. 1 tank, then 2, then 5, then 10. Each tank was hand-built, slightly different from the others, but they all worked. Pilots started flying combat missions with Shafer's homemade drop tanks, and suddenly P-51 Mustangs from the 361st Fighter Group could fly deeper into Germany than any other escort fighters. They could reach targets that were supposed to be unreachable. But Shafer's operation was still technically illegal. He still didn't have authorization. He was still violating regulations. And eventually, the officers found out. When Colonel Thomas Christian, commander of the 361st Fighter Group, discovered what Staff Sergeant Shafer had been doing, he had every right to court-martial him on the spot. Unauthorized modifications, unapproved equipment, disregarding chain of command. But Colonel Christian was a pragmatist. He'd seen the results. His pilots were flying longer missions. Escort ranges were extending. Bomber losses were dropping. So instead of court-martialing Shafer, he made a different decision. He filed an official report recommending Shafer's design for immediate adoption across all fighter groups. The report went up the chain of command, from group to wing to division to 8th Air Force headquarters. And for once, the military bureaucracy moved fast. Engineers studied Shafer's tanks. They ran calculations. They did stress tests. And they realized this farm kid from Iowa had somehow designed a fuel system that worked better than anything the official contractors had produced. By early 1944, the Army Air Force authorized mass production of 150-gallon drop tanks based on Shafer's design. Factories in England began manufacturing them properly, with better materials, better welding, better quality control. But the basic design, that was all Shafer. The impact was immediate and enormous. In March 1944, P-51 Mustangs equipped with the new long-range drop tanks escorted bombers all the way to Berlin for the first time. The mission was a turning point. German fighters that had operated with impunity in their own airspace suddenly faced swarms of American fighters that wouldn't leave. The Luftwaffe started taking catastrophic losses. By D-Day in June 1944, the Allies had achieved air superiority over Western Europe. German fighters were so depleted they could barely contest the invasion. Historians estimate that extended-range P-51 escorts reduced bomber losses by 60 to 70% compared to the dark days of 1943. Thousands of bomber crew lives were saved because one mechanic refused to accept impossible. And what happened to Staff Sergeant Shafer? He was awarded the Bronze Star for his innovation. He was promoted, and after the war, he went back to Iowa, back to his farm, and rarely talked about what he'd done. In interviews late in his life, Shafer downplayed his contribution. He'd say, "I just built some fuel tanks. Anyone could have done it." But that wasn't true. Hundreds of engineers had access to the same materials, the same knowledge, the same problem, but they were constrained by regulations, by procedures, by the way things were supposed to be done. Shafer succeeded because he ignored all of that. He saw a problem, he saw a solution, and he built it. Consequences be damned. The P-51 Mustang is remembered as one of the greatest fighter planes in history. It's in museums, it's in movies. It's the symbol of American air power in World War II. But most people don't know that the Mustang's legendary range, the thing that made it so effective, came from a mechanic's illegal side project. No fancy engineering degrees, no research grants, no official programs. Just a 24-year-old farm kid with a welding torch and a refusal to accept the status quo. Shafer's story is a reminder that sometimes the most important innovations don't come from the top down. They come from the bottom up, from the people closest to the problem who are willing to break rules to solve it. The military eventually learned this lesson. After World War II, the U.S. Armed Forces created programs to encourage field innovation, officially sanctioned ways for soldiers and mechanics to propose and test modifications. But in 1943, none of that existed. Shafer had to go rogue. And because he did, thousands of bomber crew members made it home. Thousands of families weren't shattered by telegrams that started with, "We regret to inform you." There's a restored P-51D Mustang at the National Museum of the United States Air Force in Dayton, Ohio. It's painted in the colors of the 361st Fighter Group, Shafer's unit. Hanging under its wing is a 150-gallon drop tank. Most visitors walk past it without a second thought. It's just a fuel tank. But if you know the story, you see it differently. You see a piece of metal that changed the course of the war. You see the proof that one person in the right place, with the right skills and the right determination, can change history. And you see a reminder. Sometimes the rules are wrong. Sometimes Impossible just means nobody's tried hard enough yet. Staff Sergeant Robert Shafer tried hard enough, and the sky over Europe was never the same.